This is a lesson of addition of vectors to determine a resultant by graphical methods. Now, a basic introduction, usually when we know that we have two forces acting on an object, the total resultant will be the addition of the forces. What do I mean? Now, if I have an object, which is a block, being acted upon by two forces, 40 Newton to the right, and another force, 30 Newton to the right, we will know that the total resultant force is 70 Newton. Now, if these forces are parallel, meaning 40 Newton here, and even in the opposite direction, 30 Newton, it is still addition of the forces. It's just that resultant force now is equal to 40 Newton minus the 30 Newton equal to 10 Newton. Now, what happens when I have a new scenario, when I have an object which is acted by forces which are not in parallel direction? Instead, they are at an angle from one another. To solve such questions, we will need to employ graphical methods. And by graphical methods, we have two methods. One is our parallelogram method, and the other is the tip to tail method. Okay, so now I'm going to show you an example of how I solve this question. Let's look at the example. So in this example, I have two forces of 30 Newton and 40 Newton acting perpendicularly on a body. So I need to determine the direction of the resultant force acting on the body using both the graphical methods. So I'll begin with the parallelogram method. Step 1 is to set a scale. So this is the instruction. I'm going to do the working. So I set a scale of 1 cm representing 10 Newton. Step 2 is to represent the forces using arrows. So now what I'm going to do is, first I'm going to draw a dot. This represents the body. Next, I'm going to use a ruler to measure 4 cm to represent 40 Newton. And then because they're acting perpendicularly, so I have to measure a 90 degree using a protractor. And then 3 cm. Okay, this is the completion of step 2. Step 3, we'll have to complete the parallelogram. All you have to do is to draw parallel lines using these two. This line to draw a parallelogram here. So, but because this is a rectangle, it should be easy. So I just transpose it over here, and then measure 3 cm using dotted lines. And then here, you can just connect, it should be about 4 cm. And then, for step 4, we find the resultant force or draw the resultant force. Beginning with the body to the other end of the parallelogram. representing it with a double arrow for resultant force. With that, we have finished completing the parallelogram. Now we need to find the magnitude and the direction. So for magnitude, we just need to measure the resultant force drawn. So use a ruler. I get 5 cm. So using my scale, 5 cm will represent 50 Newton. So my resultant force, my answer, resultant force is equal to 50 Newton. Now, most students will have problem with this thing called direction. Direction, basically, you just need to measure the angle of the resultant force from one of the two forces. So in this case, I'll take reference from this 40 Newton force. I'm going to measure this angle. And I'm going to use that using the protractor. And it's about 40 degrees. Okay, so the direction will be force, resultant force is 40 degrees from 40 Newton force. And there we have it, the 4 marks for the question, because each step represents a mark each. Okay, that's all for parallelogram method.